In this video, we're going to have an introduction to lines. So at this stage, we know how to solve an equation like this. We know how to solve 3x plus 2 is equal to, let's say, 17. Now, looking at that equation, you might be able to see what the solution is right away. So if you just experiment with numbers, let's say you plug in a 4. Well, 3 times 4 is 12, plus 2 is 14, not quite 17. But if you keep experimenting, you might see that a 5 will work, right? 3 times 5 plus 2 is equal to 17. Now, that number, x equals 5, we know we refer to that as our solution. So we'd call this the solution. Now, what's important to notice at this stage is that the solution is simply a single number. So the solution is a single number. Why is that the case? Well, because the original equation says, well, there's only one variable, right? 3 times some unknown number plus 2 is equal to 17. So all we had to do is specify a number, in this case x equals 5, that makes this statement true. This equation, the equation we just solved, has a special name. It's called a linear equation in one variable. So let me write that down. This equation is called the linear equation. What we say in one variable. So some special terminology associated with that equation. Now, we say it's in one variable because there's only a single one variable, and we call it a linear equation because the exponent of x is a 1. So when you have that situation, when you have a variable raised to an exponent of 1, we call that equation linear. Okay, let's say you had the following equation. Let's say you were asked to solve something like this. Let's say it was 2x plus y is equal to 6. Okay, so I can see that there's a difference between this problem and the previous problem. And that difference is that instead of only one variable, I have two variables. On the other hand, there is a similarity. And that similarity is that the exponents, right here and right there, the exponents are both a 1. So in this case, we'd still call it a linear equation, but it wouldn't be a linear equation in one variable. We'd call this a linear equation in two variables. So let's write that down. This is a linear equation in, we say, two variables. And the two variables in this case are, of course, x and y. Okay, so the question is, well, what would it mean to solve this equation? Now, up here in the previous problem, I only had to specify a single number, right? And that's because there was only one variable. But here there are two variables, so it makes sense that you'd have to specify two numbers. Now, you have to specify two numbers at the same time so that when there's a value for x and a value for y given together, the whole statement is true. And let me give you an example of what I'm talking about. Consider x is equal to 1 and y is equal to 4. So do you see how I specified two numbers, one for x and one for y? And I could ask myself, is this pair of numbers a solution? Now notice I'm specifying a pair, and that's because there are two variables. So is this pair a solution? So is this pair of numbers a solution? How could we check it? Well, we could check it in the way we checked x is equal to 5 above. You'd simply take the 5 and plug it in and make sure that you have a true statement. But here I don't have to plug in just x, I have to plug in y as well. So we're going to plug in the pair of numbers and see if we have a true statement. Let's do that. Let's plug in 1 for x and 4 for y. So this will be our check. So 1 for x, so it's going to be 2 times 1 plus, well, y, and y is 4. So plus 4. And the question is that equal to 6? And I see that it is, right? Because 2 times 1 is 2, and 2 plus 4 is equal to 6. So what does that mean? That means that this pair of numbers, 1, 4, that they constitute one solution. So it's interesting that a single solution is not a single number. It's a pair of numbers in this case, and that's because you have two variables. Let's go ahead and see if we can find other solutions to this equation. Maybe there are other pairs of numbers that work. So let me go ahead and write the equation down here again. This was our equation in two variables. 2x plus y is equal to 6. And we notice that we have one pair already, right? We have the pair 1, 4. So let's create a little table over here to organize the pairs. Oops. Okay, so the first pair that we have is 1, 4. Okay, are there other pairs that might work? Well, what you have to do is you have to find a combination of numbers and try them at the same time. So how about I just pick randomly? How about I pick x is equal to 3? Now if x is equal to 3, do you see what y would have to be? Well, if I take the 3 here, it would be 2 times 3, which is 6, and y would clearly have to be 0. And you might say, oh, I can play that same game the other way. I can choose x to be 0. And if x is 0, well, 2 times 0 is 0. What would y have to be? Y would have to be 6, because then 0 plus 6 would be 6. So those were sort of easy pairs because, well, if one of the coordinates, that is, if one of the values, x or y was 0, then it was quite easy to find out what the other variable had to be. What if I chose something like this? X is equal to 4. Well, it's not as easy, right? Because if I plug in a 4 here, then I have to sort of, in my mind, think about, oh, well, what does y have to be? Now, if I actually want to write that out, and if I don't want to just try to do that in my head, here's what I'd do. I'd replace the x with a 4. So it'd be 2 times 4, right? You see the x has been replaced with the 4? Plus y is equal to 6. Well, what does y have to be? 2 times 4 is 8, plus y is equal to 6. Well, let's see. If I subtract 8 from both sides, I see that y would have to be what? In this case, y would have to be negative 2. So when x is 4, I found that y has to be negative 2. Now, what do I have at this stage? I have, well, how many solutions? Remember, a solution is a pair of numbers. So 1, 4 is one solution. 3, 0 is a second solution. 0, 6 is a third. And 4, negative 2 is a fourth solution. So I can see that I have 4 solutions, and each solution is a pair. Now, we often write this pair in a special way. What we do is we use parentheses, and we write the x first and the y second. So the pair of numbers 1, 4, that is when x is 1 and y is 4, is written like this, 1, 4 in parentheses. And likewise, the next pair of numbers would be written like this, 3, 0. The next pair would be 0, 6. And the fourth pair I'd write as, let's see, it would be 4 for x and negative 2 for y. Now the order certainly matters, right? This number refers to the x coordinate, and that number refers to the y coordinate. So not only is this a pair of numbers, it's an ordered pair, because the order in which you write it matters. So this is what we refer to as an ordered pair. Now the question is there a way of representing this ordered pair geometrically? And this set of ordered pairs geometrically? And the answer is yes. What we're going to do is we're going to plot these 4 ordered pairs in a rectangular coordinate system. And we're going to notice something very interesting about our line. So let's go ahead and do that here. So I've got, I'm going to create a rectangular coordinate system. So I have two axes. I have an x-axis and a y-axis. So this is the x-axis and this is my y-axis. And what I want to now do is I want to scale each of the axes. So I'm going to go to, because I see a 6 here, I'm going to go to 6 in all directions. So let's do that. It's going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And I'm going to label these 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, -1, -2, -3, -4, -5, -6. And going down, it's going to be -1, -2, -3, -4, -5, and -6. Okay, let's go ahead and plot these four ordered pairs. So first of all, we're going to plot 1, 4. So 1, 4 is x is 1 and y is 4, as we've talked about. And what about the next one, 3, 0? Well, x is 3, y is 0, which would be here. So it's a second point right there. And the next one would be 0, 6. 0, 6 is going to be way up here, right? X is 0 and y is 6. And then the next one would be 4, -2. So x is 4 and y is -2. So let's see, 4, -2, where would that be? 4, -2 would be down here. Okay, and if I keep plotting more and more ordered pairs for this line, and this line was, remember, 2x plus y is equal to 6. If I keep plotting more and more ordered pairs that make this equation true, I'm going to find that I get a line that has all these points lie a line like so. Okay, if we get more and more points, we're eventually going to make that line darker and darker, and it's going to look like this. So what we have here, or what I'm noticing, is that if I take the ordered pairs that make this equation true and I plot them on a rectangular coordinate system, I end up getting a line. And that's exactly why this is called a linear equation in two variables. It's called a linear equation because when you plot the ordered pairs that make it true, like I did, you end up getting a line. And we'll graph lines more in the next in upcoming videos.